Hello, my name is Maab Balla, and today's work assigned for me is the state of art of ChatGPT and reinforcement learning. The outlines I will cover through this presentation is first a motivation about ChatGPT, and then the ChatGPT and the model based on ChatGPT's GPT 3.5. Then the last recently announced GPT-4, and the methods they use, which is reinforcement learning from human feedback, and they use special policy optimization algorithm, which is proximal policy optimization algorithm. Then pipeline for our avatar-based like living AI robot using this method, and the challenges and the issues we can face through realizing it or deploy it in the real world scenario, and what is next after that. Um, First, we will talking about ChatGPT, which like an AI chatbot application which uses powerful language models, large language model GPT-3 and GPT-4, and it was like introduced in late November 2022, and it like quickly gained popularity, attracting 1 million users within just 5 days, and 100 million users within 2 months. And we can like the model behind ChatGPT is GPT 3.5, which is based on GPT 3, and GPT 3 gained 1 million subscriber users within 2 years, but it wasn't open for public. And GPT 3.5 actually uses the same pre-training dataset as GPT-3, but with additional fine-tuning method. ChatGPT actually is just one of more than 50 GPT-3 models that made by OpenAI, and in 2022, the InstructGPT was released, and it uses the reinforcement learning with human feedback to fine-tune the GPT-3 model. And this model like allows the ChatGPT to understand this method allows the ChatGPT to understand the natural like the user prompt and respond to the user in a friendly and conversational way. And it also like learn from the user, like during the conversation, and like as the time goes, it improves its accuracy. ChatGPT can also like be integrated with other platforms such like Slack, Facebook, Messenger, or Skype. And this like integration can allow users to access their virtual like assistants from any of these platforms. And it also can be used to make tasks like customer service or sales inquiries or other tasks, right? Finally, like in March 14, 2023, GPT-4, which is more powerful than GPT 3.5, was released, and it opened like for public, but like it's a limited way via ChatGPT Plus, and it can process up to 25,000 words, and it can handle images also, and like with this like more abilities or capabilities, we can like expect more impressive like AI applications in the future. So there is like some alternatives to ChatGPT. The first one is Perplexity, which is the first commercial platform based on WebGPT, and it includes live web searches in conversation, make it a unique option for users who prefer web searches as part of their conversation. The next one is the Google part, which is based on Lambda 2, and it is said to have a public release like in March 2023. And it's like expect to offer more human-like conversation experience. And for iOS users, we have Kurapu with its option also, which combines the OpenAI ChatGPT and the Anthropic Cloudy to offer an accurate and efficient conversational AI experience. And like if we looking for more powerful conversational AI system, we had Fudan University MOSS is an excellent option here, and it is used like with it is 430 billion tokens and 20 billion parameters. It also expects to offer a highly sophisticated conversational experience. And then we have like Facebook Blender Pod, which also another conversational AI system, and it is have like more natural and engaging conversations with users, and it uses a combination of neural network architecture to offer a highly accurate and effective conversational experience. Let us take like an overview of how like ChatGPT ChatGPT, as we said, is like fine-tuned model of GPT-3 using the reinforcement learning with human feedback on GPT 3.5, and the fine-tuning process like used to improve the performance. The fine-tuning process is involved like both supervised learning and reinforcement learning with human trainers. In the supervised learning, or the SFT phase, the model was provided with conversations where the trainers played both sides, the users and the AI assistants. Here then we have the reinforcement learning human trainers rank the models previous responses to create the reward models that the model was like again or next fine-tuned on using several iterations of the proximal policy optimizations. Then the PPO algorithms were used because like they are cost-effective and faster than like other algorithms like trust region policy optimization. So GPT-3 like first was released in 2020, and it was like at that time there was the largest publicly available model, which trained on 300 billion tokens and a final size of 175 billion parameters, but it wasn't open for the public. It was trained on trillions of words sourced from the web, making billions of connections, and it is very good for predicting the next word for any given month. Then in 2020 January, GPT-3 was released, and it has three variants. Each like one of them is 1.3 billion, and the other is 6 billion, and also a variant of 175 billion parameters. And the main feature of GPT 3.5 is was like to eliminate the toxic output to some extent by working within specific policies of human values. And GPT-3 also called like what we introduced previously, InstructGPT, and but like InstructGPT is 100 times fewer has 100 times fewer parameters than GPT-3, and it was trained on the same dataset, but with additional fine-tuning process that add concepts here. The reinforcement learning with human feedback, what we just explained. And if we like looking at GPT 3.5, which the architecture of it is still like not officially confirmed by OpenAI, but we can believe like it is similar to InstructGPT, and it was trained with human trainers who evaluate around its response to prompts, and its feedback was then like incorporated into the model to fine-tune its answer to align with the trainers and trainers' preferences. Then GPT 3.5 was trained on a combination of text and code before end of 2021, and it's learned to understand the connections between sentences, words, and parts of words by consuming vast of amount of content from web. Rather than releasing GPT 3.5 in its fully trained form, OpenAI utilized it to develop several systems specifically optimized for various tasks or accessible via OpenAI API. One of these systems is Text DaVinci 003, and it is said to handle more intricate commands and than models constructed on GPT-3 and produced higher quality, longer form writing. So while we may not have conserved information about GPT 3.5, but the developments that have emerged about its capabilities have been impressive, and we can expect that OpenAI continues this in the recently released GPT 4. So before going through GPT-4, let us talk about the in detail with the RLHF, the reinforcement learning using human feedback, and reinforcement learning using human feedback is a subfield of artificial intelligence, and it focuses on using human feedback to improve machine learning algorithms. This method is used to address the limitations of the supervised and the unsupervised learning, where just the machine learning algorithms have limited ability to learn just from labeled or unlabeled data. So how does the reinforcement learning from human feedback work? Here, we can imagine we have a robot, and the robot wants to learn how to talk like humans. So this robot has some language model that help him to understand words and sentences. First, the robot will say something like using this human this language model. For example, he might say, "I'm a robot." Then the human will listen to what the robot said and give him feedback on whether it sounded like a natural sentence human would say. The human might say that is not quite right, or human don't usually say I'm a robot. So the robot will take this feedback and use it to update its language model, and he will try to say some sentence again using the new information he received from the human. This time he might say something else, and the human will listen again, give the robot more feedback. This process will continue until the robot can say a sentence that sound natural for a human. So the reinforcement learning with human feedback incorporates human expertise and knowledge into the machine learning algorithms to improve their performance and ability to solve more complex tasks that cannot be solved with the supervised and unsupervised learning. And the human feedback can be provided in various forms, such as rewarding or punishing the model's actions, providing labels for the unlabeled data, or adjusting model parameters. And the reinforcement learning with human feedback is a powerful tool, and it like allowing us to perform better on more complex tasks and impossible to solve in another ways. And so if we go through ChatGPT 4, GPT-4 like the last recently released by OpenAI, and it is a multimodal language model that understands both text and images, and it has a context length of 32,000 tokens, which means it like processes much larger amount of information than its preceded GPT-3. And also one of the most impressive features of GPT-4 its ability to understand and connect the context in images to the social understanding of language. This has resulted in a noticeable behavior in visual question answering and image captioning, which could be particularly beneficial for visually impaired or blind individuals. So also we can see like GPT-4 is more multilingual than GPT-3, and it has better steerability. It can also accurately respond as many as like 26 languages, and can control its responses by choosing specific personality. But like also uh, OpenAI has not revealed much information about the architecture of training the specifics of GPT-4, but we can estimate that the number of parameters used for the training, it could be about 100 trillion. And also like there is another company like DeepMind or Hugging Face who are also working on developing same models. We have also like Microsoft released EOS, MOS1, and DeepMind has Flamingo, which are both capable of engineering in dialogue on images, image captioning, and visual question answering in a zero-shot manner. And for like fine-tuning this GPT-4, OpenAI use the same as GPT 3.5, the reinforcement learning from human feedback, and it also like involves the same supervised language model training and also gathering human label preference data, and then fine-tuning the language model to maximize the reward, and with the same goal, which is to improve the model alignment and the factual correctness and the steerability. And also one of the exciting things about GPT-4 that it can handle both text-only or text vision tasks, and it is improved like capability is handling the illegal or unsavory request. It also has the ability to use image inputs, allowing users to specify any vision or language task by enter first text and images. This means that like it can interpret complex imagery such as chart, memes, and academic papers, screenshots. And if we go through the capabilities of GPT-4, one of the major focuses is like the improving of the alignment, the ability to follow the user intentions while also making it more truthful and generating loss offense dangerous output. And this significant improvement from its predecessor, which struggled with generating biased and inappropriate content, such as GPT based on GPT 3.5. And GPT-4 also can be can be broken into broken down two domains, the text only and the text vision task. It is like improved its capability, the capabilities in interpreting complex images, such as what we said before, and it also like still have, however, like the extent of its visual reasoning capabilities is still unclear as image inputs are not yet available for like public use. And also, GPT-4 has shown improvement in factual correctness with 40% higher than GPT-3. And also GPT-4 has demonstrated the ability to transform the hand-drawn sketches into functional HTML web pages, which is a significant step forward in the field of multimodal AI. So if we would like to talk about the reinforcement learning from human feedback in details, and as a model can learn faster and more accurately using this through the trial and error uh, alone, and the traditional reinforcement learning method um, depends on the rewards or punishment provided by the environment, whereas the human-in-the-loop approach involves additional feedback from human. And there are different approaches using human feedback for the reinforcement learning, including the learning from demonstration, where the agent learns by observing and mimicking the action of a human expert, or using the human evaluations or ratings to guide the agent learning process. So here in the reinforcement learning from human feedback, which has the potential to improve the performance and the efficiency of the machine learning models, especially in the situations where the trial and error learning is impractical or time-consuming. It also presents new challenges as managing the quality and the consistency of the human feedback, and also avoiding the biases or errors introduced by the human evaluators. So here we can see it as we can see the training process can be see as 3 steps. The first is the pre-training a language, the language model, then the gathering the data and the training the reward model, then fine-tuning the language model with the reinforcement learning. In the first step, we create a language model that can learn the structure of the language from the language large amount of text data. Then in the next stage, we gather the data and train a reward model that provides feedback to the language model on its output. Finally, we fine-tune the language model using the reinforcement learning, which uses the feedback from the reward model to update the language model's parameters. So as we started, we have this a language model that already has been pre-trained, and with classical pre-training objective. For OpenAI, they use a smaller version of GPT-3 for its first popular RLHF model, the InstructGPT, and also Anthropic use the transform models ranging from 10 million to 52 billion parameters trained on this task. Also, DeepMind used about their 280 billion parameter model, what is called Gopher. This initial language model can be used to train on additional text or condition, but it is not necessary to do. For OpenAI, they fine-tuned it on human-generated text was preferable, and also Anthropic generated their initial language model by distilling an original language model on context clues for their helpful, honest, and harmless criteria. These are both sources of what we refer as expensive augmented data, but it is not required for training the for the training our language model in the first stage. So for the next step, where we gathering the data and training a reward model, here is the process of generating the reward model, what we can call also a preference model, and calibrate it with the human preferences. So here's a reward model calibrated with the human preferences, and the language model for the reward model can be fine-tuned on additional text on conditions, and to generate the training dataset, we have like here to generate this dataset of prompt generation pairs of the reward model, like a set of prompts is sampled from the predefined dataset. This is the samples, and the prompts then pass through the initial language model to generate the new text. Then the human narrators are used to run the generate text output from this language model. Then the ranking are used to compare the output of multiple models to create much better regularized dataset, as opposed to human applying a scalar score directly to each piece of text. So when it comes to optimizing the language model with respect to the reward model, there's different approaches we can take. One of these most is using the reinforcement algorithms, which involve a cycle of action, observation, and reward. In this case, the action is generating text, and the observation is the generated text, and the reward is the score assigned by the reference model. The RL tries to maximize the expected reward over the time by adjusting the parameters of the language model. The training process can involve exploring new text generation strategies to find more optimal ones and exploiting non-good strategies to reinforce them. So one algorithm used for this, or the algorithm they use for this, is the proximal policy optimization, which is a type of the policy gradient algorithms that seeks to that try to optimize the parameters of the language model by maximizing the expected reward, by limiting the size of the update to prevent the catastrophic forgetting of the previous language knowledge. And the next step will be like the fine-tuning with the reinforcement learning, where we have like an reinforcement learning agent that try to interact with an environment. In this case, or this step, the environment is the language model, and the agent provides a prompt to the language model, which generates a sequence of tokens in response. The agent then receives a reward signal based on how well the language model output matches the target output. This target output can either be provided by a human expert or generated by another model. The RL agent's ultimate goal is to learn policies that maximizes the expected reward over a sequence of prompts. It aims to generate outputs that are as close as possible to the target output provided by the human expert or other model. This accomplished by iteratively training and updating the RL agent policy using the reward signal received from the preference model. The RL agent policy is essentially a set of rules that dictate how the agent selects action, or in this case, the prompts, in response to the language model output by updating this policy based on the feedback from the reward model. the RL agent um, can like improve its ability by generating outputs that can align with the human preferences. So to fine-tuning the language model with the reinforcement learning, we use the PPO, and the goal is to update the policy of the language model based on the reward function that combines a preference model and a limitation or concentrate on the policy shift. The reward function penalizes the policy for moving substantially away from the initial pre-trained model with each training batch, and can include additional terms such as pre-training gradients. This constraint is designed to prevent the fine-tuning policy from becoming uninterpretable or going away from our goal. And the updated to update the rule is the parameter update from the PPO is try to maximize the reward matrices in the current patch of the data. Then this PPO, which is a trust region optimization algorithm, try to use this constraint or limitation on the gradient to ensure the update step does not stabilize the learning process. So if we make it in summary, the reinforcement learning with the human feedback involves iteratively fine-tuning the language model policy using the reward function and the constraint, and gradually improving the quality of the generated text. And by evolving this human feedback in the form of preferences or constraints, the RLHF process can learn to generate text that better meets needs and preferences of human users. So if we go deep on what is this proximal policy optimization algorithm, reinforcement learning algorithms such as Q-learning or policy gradient method can use for training these different machine learning models. And the goal of these algorithms is to learn a policy that maximize the expected reward and the inferred reward function. So one reinforcement learning algorithm is most popular is proximal policy optimization with adaptive KL penalty or the clip gradient. So we can say the proximal policy optimization is a model-free, online, and on-policy actor-centric algorithms that is used to optimize the policies of an agent in an environment. It learns directly from the experience without requiring a model of the environment. So it was introduced by OpenAI in 2017, and it has two versions, the PPO penalty and PPO clip. The PPO penalty or the adaptive KL penalty, it helps to regulate the KL divergence between the new and old policies, and this algorithm seems to strike the right balance between the performance and the comprehension. The idea behind the PPO is to optimize the policy by iteratively updating it in a small steps while ensuring this policy update does not go away far from the current policy, and is achieved by using proximal objective functions that penalize large changes in the policy. And when training using the PPO, the policy is updated to maximize expected discounted rewards, which causes the policy to become more focused on actions that have resulted in high rewards in the past. However, this can sometimes lead to policy getting stuck in local optima or failing to explore other uh, um, potentially better actions. So to address this, PPO using the other like the clipping mechanism that limits the size of the policy update, preventing it from deviate too far from the previous policy to encourage the policy to explore other actions while maintaining some level of stability during the training. Also, it includes entropy regularization terms that um, encourages the policy to remain sophisticated, helping to ensure it to continue explore throughout the training. Also, like one important aspect of PPO, it used an on-policy approach to train the sophisticated policy, which means that it samples the actions according to the latest version of its policy during training. The amount of randomness here in the action selection depends on both initial conditions and the training procedure. So we can say like PPO strikes a balance between the exploration and the exploitation, which is like important for effective in reinforcement learning. And by limiting the policy update and encouraging it sophisticatedly, the PPO enables the agent to explore the environment while still learning from the experience, the past experiences. And if we go through like through the two types, first the PPO penalty, where it is also what we can say it is a way to balance the exploration exploitation during the policy optimization, and using the adaptive KL penalty. So if we take it's in simple, first we try to set up the policy parameters and initialize the KL penalty and target KL divergence. Then for each iteration, we try to collect a set of partial trajectories by running the current policy in the environment. Then we estimate the advantages for each time step using any advantage estimation algorithm. And after that, we compute the policy update using the mini batch sophisticated gradient descent to optimize like the surrogate objective function. So if the KL divergence between the new policy and the old policy exceeds 1.5 times the target KL divergence, to increase the KL penalty. If the KL divergence is less than or equal to sigma over 1.5 here, we decrease or the target KL divergence, we decrease the KL penalty. So we repeat these steps until the convergence. So the adaptive KL penalty helps the algorithm adjust the degree of exploration during the policy optimization dynamically, and it also encourages more exploitation if the KL divergence is too large, and more exploitation if it is too small. This helps the algorithm to avoid getting stuck in local optima and find better policies. So if we go like for next, the PPO clip or the clipped objective variant of the PPO is designed to balance the exploitation and the exploitation trade-off like between them during the policy optimization while maintaining the stability. The same goal of the PPO penalty, and it is achieved like this by limiting the change in the policy during each update using the clipped objective function. The clipped objective function ensures that the policy update does not deviate too far from the previous policy, preventing the policy from getting stuck in local minimum, the same goal. So additionally, the algorithms dynamically adjust the clipping threshold based on the relative size of the KL divergence between the new and the old. And the KL divergence too large, the clipping threshold is increased to encourage the, more exploration. If the KL dimension is too small, then the clipping threshold is decreased to allow for more exploitation. So this is the same. So if we go through like the limitations of the PPO, first the exploration. The PPO needs to explore the environment sufficiently to learn a good policy. Otherwise, it may not perform well because the policy will focus only on a few actions. So also we have like the hyperparameter sensitivity because like PPO has several hyperparameters that must be tuned for good performance. However, these hyperparameters may vary based on the environment task, making it challenging to use a PPO in practice. So PPO also may struggle when the environment has a large number of states and actions. This is because the policy updates require like computing the gradients of the objective function, which can be like complicated. PPO is also designed to optimize like for the reward signal, but like it may face difficulties learning a good policy if the reward signal is sparse or noisy. So this is especially like difficult in the environment with delayed rewards or complex objectives. Also, the like many reinforcement learning algorithms, PPO requires large of number of samples to learn an effective policy. However, like obtaining these samples can be challenging in environments where interactions are expensive or time consuming. So what is next for the reinforcement learning with human feedback? It is a promising field as like it is like the main fine-tuned method for the ChatGPT, GPT 3.5 and GPT-4, but it is still has some limitations. First, like the language model can output harmful or factually inaccurate text without any uncertainty, and this can be a problem in certain like applications or the sensitive applications. It is also like gather human preference data like gathering this human preferences data is expensive and like it can affect the performance. It's like involve the fine tuning the initial language model and labeling human preferences with the model output. Third, also it like generate the well written human text is cost like generating this is costly and expensive and like often like it requires hiring part-time staff for doing this, while the scale of the data used for training the reward model is not expensive. It's still costly. Also, like the human animators can often disagree, which like can add substantial potential variance to the training data without ground truth. So despite like these limitations, there are many unexplored design options for the reinforcement learning with human feedback to take. For example, we could improve the RL optimizer by using other algorithms that offer benefits on the existing RLF workflow, or we could use the offline RL as a policy optimizer to avoid the costly forward passes of the large model, but like they still need to explore or investigate these options. So for like then we will use discussing this pipeline for using a reinforcement learning with human feedback to train our avatar or our chit chat bot. This could be like here we have in the understand where we try to understand the user response, the user, and generate a response for it. So we can see it as mainly a two steps. The first step where we have the preference model, the reward model. The preference model is trained using a dataset of comparisons of comparisons between like the human preferences. So we can assign the score to the better response in each comparison. So then the second step is the RL policy we will use is trained to generate responses to promote autoaggressively with a reward signal provided by the PM score, preference model score at end of the response. So to stabilize this RL training, we will use PPO along with estimated KL penalty term in the reward. The total reward then is given as a combination of the PM score and the PM score and KL penalty term. So to generate additional prompts, we will for training a large language model, we will use generate new prompts using few-shot learning. The prompt is generated by the LM is combined of the dataset of prompts written by human crowd workers for greater diversity during the RL training. So it is also like we can say, note that almost all the preference modeling data should like collected from smaller model and as an initial model, and which like makes the training it with RLHF like for more smaller modeling is challenging since the samples come from smaller model tend to be out of distribution from the reference model training data. So if we go through the limitations of the ChatGPT, sometimes like ChatGPT give like wrong answers and make up responses, and it may also like have problems with logic, math, and facts. And ChatGPT can handle like up to 500 words of text, but like the ChatGPT based on GPT 3.5, we cannot like handle images, and for both we cannot handle the audio files. For the both like versions. So as it's also like not like it also has limitation information, and it is known it is only known up to September 2021, and like GPT-4 is not aware of its existence. Like if you ask GPT-4 about GPT-4, it will not know anything, and it only generate response based on this like past data. So also like ChatGPT is not like sentient being on is only a text predictor, and it cannot think or have awareness. So GPT-4 also has some limitation in creativity, like when we are if asked to write a specific kind of component, or it's like unfamiliar with another types, and so what is next for GPT models? If we like try to talk about the future of GPT models or trying to do some expectations, like the GPT-4 is like expected to have or the next model of GPT will expect to have some ability to generate and understand audio or even video, not like just image or text. However, there is like a challenge for a multimodal modeling, such as ensuring that significant information is not lost during the tokenization. How we can deal with like this through the tokenization is a basic challenge. Also, we should like focus on the AI safety. Like, we are excited about the growth of AI capabilities, but we should also focus on the AI safety. One of the challenges is the intent alignment, where we try like which means like ensuring that AI systems are aligned with our intended goals. If AI systems start optimizing our unintended goals, it could result in unintended or potentially harmful consequences. So it is also important to ensure that AI capabilities grow in tandem with AI safety. That is like why OpenAI has not yet released detailed implementation details for like GPT-4. So let us look forward for this future of GPT models and put in mind this AI safety. So until here, I will reach the end of my presentation, and thank you for listening.